So here we are on the final slide of this presentation on parallelograms. And we're supposed to show, using slopes, that this polygon ABCD is a parallelogram, and then list the 5 concluding statements about the parallelogram using the SAD acronym that we learned on the slide before. So I want you to close your eyes and imagine that you're walking through the geometry forest. Yes, it could happen. You might end up one day in the geometry forest and you might stumble upon a diagram that looks like this. And you'll wonder, is this polygon a parallelogram? I'm really wondering if it is. Well, in order to figure out if it is or not, one thing you might want to do is look at the slopes. And if the slopes are the same for any 2 line segments, we'll know that those segments are parallel. And maybe, just maybe, we might have a parallelogram. So let's start by finding the slope of segment AB. And in the end, we're going to find 4 slopes here. So I'm going to use different colors, and I'm going to be very careful to notate my work, so I really am showing it in a proper way. So I'm going to start by finding the slope of AB. Okay, so the slope of AB, I need the change in y over the change in x. Let's remember that slope is fun using rise over run or using the slope formula. And maybe it's worth writing that down real quick over here. Okay, so we wrote the slope formula down just so we have it at our fingertips. Let's go back and figure out the slope of line segment AB. So I'm going to figure out a subtraction problem for the y's, which would be 16 minus 2. And then for the x's, it would be 5 minus 1. This leaves us with 14 over 4, which reduces, of course, to 7/2. Okay, now I'm going to jump to the other side across from AB to line segment CD. So let's set that up. Now let's construct our subtraction problems. Now I'm going to do 24 minus 10 over 15 minus 11. This gives us 14 over 4 again, which again reduces to 7/2. So right now I can make a conclusion. I have a 4-sided polygon in which exactly 1 pair of opposite sides are parallel, or 1 pair is parallel. But in order to say that we have a parallelogram, both pairs of opposite sides have to be parallel. So we're only halfway done. So now let's consider the slope of line segment AD. And the subtraction problem I'm going to use now is 10 minus 2 over 11 minus 1. This is going to boil down to 8 over 10. And 8/10 reduces by 2 to 4/5. Now let's jump up to the top segment, which would be segment BC. Okay, now my subtraction problem is going to be 24 minus 16 over 15 minus 5. This is going to leave us with 8/10 again, and that reduces to 4/5. And let's remember from an earlier section in the book that if the slopes are the same, then the lines are parallel. Okay, so my conclusion now is that I have a polygon, a 4-sided polygon in which both pairs of opposite sides are parallel. So yes, this is a parallelogram. And we're going to finish by writing down the 5 properties according to SAD. So let me just write those off to the side like this. So the first property for SAD has to do with the opposite sides being parallel. So that's going to be AB is parallel to CD, and AD is parallel to BC. The second S represents the fact that both pairs of opposite sides are congruent. So AB is congruent to CD, and AD is congruent to BC. The first A stands for both pairs of opposite angles are congruent. So angle A is congruent to angle C, and angle B is congruent to angle D. The second A stands for the fact that all consecutive angles are supplementary. So I'm just going to identify two pairs. I'll say that angle A is supplementary to angle B, and that angle B is supplementary to angle C. Now I want to stress that there are other pairs of supplementary angles that I could have mentioned, but I think we get the point. And finally, the D stands for diagonals. So I'm going to go ahead and draw those diagonals in so we can make our final statement and be done with this video. Now I don't know if you can tell, but I'm having some serious pen issues. It's getting really wonky on me. Let's call this E. And we know that the D means that the diagonals bisect each other, which means that BE is congruent to ED, and AE is congruent to EC. And I'm going to let you write that down on your own. I don't know if I'm going to even be able to finish this. It might just stop working. So I'll try AEEC and BE and ED. Okay guys, it looks like we made it. This video is done. I hope you now know a few things about parallelograms. Actually, I hope you know 5 things about parallelograms.